Okay, I'm actually Luke Malone from NQ Dry Tropics. So just a quick role change there. So I work for NQ Dry Tropics in the Burdekin Cane region, and we're going to be looking at water in this session. Obviously, as we all know, irrigation is a big part of growing your crop in the Burdekin at least, and if you can get your water use efficiency up there, it goes a long way to being profitable at the end of the day in sugarcane. So I'll welcome Billy White, agronomist from pharmacist, to open up the first grower presentation. So she's looking at a few Burdekin growers at irrigation, she's specifically looking at groundwater nitrates at 5 Burdekin farmers: Brian Langdon, Brendan and Ryan Swindley, Sam Morano, and Peter Brotto. So over to Billy.
Coming into my 22nd year of farming, I farm in the Edinburgh district. We farm approximately 162 hectares of farm. I am a shared farmer. The farm itself belongs to Linda Lashman. It's been with him for well over 35, 40 years. The main crop is sugarcane, with some dabbling in side crops of mung beans.
Hi, I'm Sam Morano. I've been farming in the Burdekin my whole life in the Inkerman area. I started off on the farm with my uncle and my father 22 years ago. After hearing from Catalyst off my neighbour and what he was being involved in with his water projects and stuff like that, it gave me the initiative as to where the business was going, as to go and talk to pharmacists and be involved in Catalyst and see what options they had for me to make my business become more efficient.
Well, I got involved with Project Catalyst in the sense that I feel that you have to be proactive because farming itself is moving towards more sustainable practice. I think would be the best term to use. So we've got to be much more aware of our environment.
With our groundwater nitrate trial that we're doing this year with pharmacists, we've applied 100 units of N, 170 units of N, and a strip trial of ON after seeing how high my nitrates in our water were.
In our paddock that we're actually doing for monitoring on, we're monitoring every irrigation different, which is something we never did. I've monitored, maybe, to be honest, probably once every couple of years I get a water sample done. A bit more the last few years, but certainly nothing as precise as what we're doing now. We've done strip trials in our last season, in the 2017 season, with different rates of fertiliser, different types of fertiliser, which hopefully will give us a bit better indication in the 2018 season where we can go. I've found the whole process of the monitoring of Catalyst, I think, has been a very easy process.
You want to hear it twice. So for the people I haven't met yet, I'm Billy and I work for pharmacists in the Burdekin. And for the last 12 months we've been doing some work with the groundwater nitrates. We've got a few new faces this year. We've new participating growers. So I've got to say thanks to Brian Langdon, Brendan and Ryan Swindley, Sam Morano and Peter Brotto for basically letting me harass them. So groundwater nitrates in the Burdekin, so why are we doing this? We already know there's a number of hotspots around the Burdekin with nitrate in the groundwater, but what we don't know is whether these areas have spread, if any new ones have popped up, or even the levels of the nitrate in these areas, whether they've gone up or down over time. The nitrate that's in the groundwater is in a plant available form and it's negatively affecting growers' CCS. So when I talk to growers in nitrate areas, they all come back with the same sort of comment that their CCS has been doing a steady decline over the last few years, and we have a feeling it's to do with the N going through the water. And to be frank, we don't know a great deal about managing groundwater nitrate areas. We know we can reduce our fertiliser rates, but we don't know by how much. We know that nitrogen's going on the paddock, but we don't know how much is going through our irrigation water. and we don't know how much of the nitrogen in the water the plant can use. So it's kind of like tipping a bucket on your head of water. So how much can you drink from that bucket of water? And then how do the nitrates behave throughout the year? Do they hold steady? Do they fluctuate? Do they spike? So this is all stuff we haven't quite answered yet. So what we've been doing over the last 12 months, we've got 4 bores that we've consistently monitored. We harvested 2 replicated strip trials last year, and we've implemented 3 more to be harvested in this season. We've got end of row sensors at the top of the block, and these sensors are telling me when growers are irrigating and how long for, in an effort to help them record their irrigations. And then using those records and the regular monitoring, we're working out how much N is being applied through irrigation. So that's because I'm pointing it the wrong way. Okay, so we have 4 sites that we've been monitoring, one in Airville. We were monitoring Site 2 last year, just outside the Home Hill Township, except we've stopped there and we've moved up to Site 5 in Upriver Home Hill, and then we're continuing to monitor at Site 3, the 2 bores at Site 3 and 4 out near Inkerman. So this is the monitoring data from the last 12 months. This is my favourite graph. So what it looks like is over 12 months, the nitrates hold fairly steady. They've got a fairly steady level there. However, you'll notice some spikes. So we've got a spike here, one up here. And I actually noticed the spike after looking at some data following this sort of period here. And when I overlaid the rainfall events for 2016 and 2017 over the monitoring data, it looks like they spike following a heavy rainfall event. This one here and then this one here. However, we didn't get a spike in March. And sort of thinking about it, when you look at the dates that these rainfall events have happened, they occur following a period of fairly heavy fertiliser application. So where we have our spike here in, say, December, it's like people are putting their return fertiliser on. And then over here, our spike in late April, everyone's putting their fertiliser mix down. However, we didn't get a spike in March. So this suggests that the nitrates will spike following a heavy rainfall event following a fertilising period. What it also suggests is that irrigation isn't pushing the nitrate into the water, it's rainfall, which is, yeah. Okay, so we've started trying to answer how much N is going on the paddock through irrigation. And this is just the irrigation data from trial site 1, where we just implemented a trial in September. And the grower's been grabbing samples for me from every irrigation, which we've been sending to the lab for analysis. And working off an approximate per irrigation volume of 0.8 megs per hectare, which we've measured that, but we haven't measured every irrigation just yet, so these are estimate numbers. The paddock's been irrigated 10 times since September last year, and using the 0.8 megs per hectare and the nitrate levels, it appears that about 98 kilos of N has gone on the paddock since September. What we don't know is how much of that N the crop has actually used so far. Okay, so this was one of the trials we harvested last year. And what we just wanted to check basically whether the grower could reduce his fertiliser rate without losing productivity. So the grower in this case already applied 170 units of N, and I got him to up the rate to the 6 Easy Steps recommended rate. And in a second return crop of Q183, we found no significant difference in cane yield, CCS or sugar yield. So the nitrate, that should say nitrate nitrogen level, but it's 12 milligrams of nitrate N per litre. So if we put that into kilos of N, that's 12 kilos of nitrogen per megalitre applied, and if you apply 10 megalitres of irrigation every season, that's 120 kilos of N. If you apply 20 megs, that's 240 kilos of N over a year. And yeah, just so, as I said before, no significant difference. Matt, do you want to hop up for a second? So Matt just ran some economics for me on this trial.
G'day everyone, my name is Matt Thompson and I'm an agricultural economist at the Department of Agriculture. So basically my role is to provide economic support to Project Catalyst along with some other economists in the other regions. And essentially, basically we want to calculate or compare the relative profitability of the different treatments. So to do this, we calculate the revenues from the production data, from the market prices, and then we subtract all the variable costs. And this gives us the gross margin. So up here, we have in the graph here, just comparing the variable costs for each treatment. In blue, we have irrigation costs. In light blue, the levies. In green, the fertiliser costs. And then in orange, the dark orange, the irrigation. And then the weed control costs and the cultivation. Okay, so essentially the harvesting costs at the bottom there are related to cane yield. And because cane yield was very similar between the treatments, so with the harvesting costs, so you can see there just a $3 difference. But you can see the big difference in costs there are in green, the fertiliser costs. Obviously, with the higher rate, the 200N, you're applying more fertiliser, so you have higher costs. And in this case, around $66 per hectare more. Okay, so this graph compares the average gross margins for the treatments. So to get this, we've calculated the gross revenues and then taken away those variable growing costs. On the left, the 170, on the right, the 200. And then the error bars at the top, these show the 95% least significant difference. So essentially, if these are overlapping, it shows no significant difference. But if they're not, it shows a significant difference. So just comparing the gross margins between the treatments, you can see the 170, around $200 per hectare better off, higher average gross margin. But the stats analysis wasn't significant, so we can't confidently say that the differences are because of the N rates. Okay, so I'll just pass it back to Billy. Cheers.
Okay, thank you, Matt. So this was the second trial we harvested last year. The grower actually came to us in this case and said, I'm getting no sugar, what do I do? And we took that opportunity to drop his rate quite a lot more than he currently was. So the 6 Easy Steps recommended N rate for this particular paddock was 200 kilos of N per hectare. The grower was already applying 140 and we dropped it down to 100. And again, in a third ratoon 240 crop, we found no significant difference in cane yield, CCS, or sugar yield. And so just at this particular site, there was it wasn't significant, but there was a slight drop in tonnage. The grower picked up 0.3 units of CCS, and we ended up with essentially the same number in sugar yield. So there's potential there that even if you did drop a little bit in tonnes, if you pick it up in CCS, it's a win-win in the end. Equal the 6 Easy Steps recommended when you combine it with the fertiliser rate. But So this data here just suggests that it was quite a dry year last year. So at this particular site, quite a significant amount of N was taken up by the crop through the water. So what have we learnt in the last 12 months? It looks like that the crop can use a significant amount of N from the irrigation applied. The nitrate levels hold steady throughout the year, except they appear to spike following heavy rainfall in a fertilising period. And what we're hoping is, with continued monitoring and trials, we're hoping to see some significant benefits to water quality and growers, reducing growers' input costs. So by doing more work like this, we can increase their confidence in using nitrogen in their irrigation water as part of their fertiliser budget, which would in turn reduce the amount of artificial fertiliser, so granular or liquid, that they apply to the paddock. And there's a few challenges with this particular project. Seasonal variation and risk management. One of the major concerns of growers in this area is we've had dry years for 7 or 8 years. What happens if we reduce our fertiliser rate and then have a wet season, and then we're not irrigating, we're not applying the N, and then we lose productivity? Unfortunately, I can't answer what happens in a wet year until we get a wet season. But we're going to continue monitoring the bores in the hope that we do get some rain soon. We're still working on determining the amount of nitrogen applied through irrigation water. We're trying to facilitate, second point is crop uptake of the nitrogen. We're doing more work there with fertiliser rate trials and biomass sampling, so we can assess for nitrogen uptake. And yeah, so the second point was working out how much N is applied through irrigation, and we're just working out, we're trying to facilitate that through making irrigation records an easier process and continuing to monitor the bores. And so going forward, like I said before, we've got 3 nitrogen rate trials in at the moment. 2 are 170 N versus 100 N. And 1 is 185 versus 155 versus 125. All of these trials have 0N sections, which we will biomass sample in an effort to work out nitrogen uptake. And as I said before, we're going to keep monitoring the bores to see if they continue behaving like they are, and if in the hope that we get a wet season. Okay, thank you. Any questions? Nope.
Are there any questions for Billy before you leave, Billy? One in the back. Tony?
Billy, I guess all the irrigation's furrow?
Yeah.
Do you think you would get the same results with overhead?
Well, there's only one overhead system in the Burdekin, and it's in the Briar, but yes. Like, the N's still going on. I'm not sure the exact difference between furrow, the volume applied through furrow and the volume applied through overhead, like the difference there, but you'd still be putting N on.
Thanks, Billy.
Any other questions?
Happy days.
All right.
Cool.
Well, thanks very much, Billy, for that presentation. I think it's quite interesting, probably something farmers have been suspecting for some time in the Burdekin, is that there's sort of nitrate levels there in the water, but I guess going forward it's going to be interesting to see sort of how we can look to offset our nutrient inputs, with bearing in mind that at the end of the day it's our bottom line we're looking at. And if we can improve our profitability while improving, the environmental benefit and the nutrient to the Great Barrier Reef, well, it's a win. And I guess that's what Catalyst is all about. So next presentation, we've got Mackay growers, John, Helen, and Dean Pestiga, and we've got Mackay pharmacist Kylie Bazzini presenting. Dean, Helen, and John farm 700 hectares in the Mackay district. In Marion, and they're looking at variable rate irrigation application through overhead irrigation. So looking to improve their water use efficiency, maximise their yield by matching their irrigation application according to crop characteristics, paddock and soil characteristics as well. Kylie.
Does this one work? I apologise for my voice right now because I'm sick, so I'm living every presenter's nightmare right now. So as was just introduced, this is with the Pestiga family, and I'm just going to get Dean up and he's going to give you the background of what they've been doing on their farm and everything like that.
Cheers, Zoe. So I guess we got to this point with the overhead irrigation. We've got about 450 hectares under overhead, and we're just looking to improve water use efficiency and reduce runoff, lower energy costs, and it's nothing new, the concept, but there's probably new technology out there that we'll try and utilise a little bit more. So we've only got about 3, maybe a little bit over 3 meg a hectare. So that's at 100% allocation. So we're looking at about around 80% at the moment. So yeah, not a lot there. And so the girls can go through and give you the details. So, cool.
So in my discussions with the Pestiga, when I initially met them, they outlined they wanted to create a water management system that was A, sustainable, where it reduced runoff, electricity and labour costs, and efficient a system that only applies what is required in the right areas. A system, an innovative system, one that can be built on and adapted as needs change, and a holistic system, an all-encompassing system that takes into account soil variety, soil type I should say, cane variety and any sort of paddock limitations. Now with this in mind, a variable rate pivot could do this, but with any sort of advancement in technology or investment on a farm, you need to work out, is it actually viable? So that's where they approached pharmacists, where we did some spatial analysis for them. Now, first thing we did was EM map the property. Now, the Pestigas already knew that this was a variable farm, but they weren't sure of the extent. Now, the EM map basically identifies different soil characteristics, but more so where the boundaries are of these characteristics. Where's the pointer? Okay, in the dark blue areas, that's more of a heavy soil type, and as you go down the profile, down into our red, that's our lighter soil type. On the right here, we have a 16-year yield map average, and you can see that in our high EC areas, the dark blue, we're having low yields, and that's because this is a dark clay soil, so you are getting incidences of waterlogging. Now that's their pivot they've got there, and that square is actually where our trial paddock is. But what do you do when you have such a variable paddock like this? Because realistically, a flat rate of irrigation is always going to limit its productivity because it's a double-edged sword. You're watering to one soil type, but the other is suffering. So with this in mind, they were like, yep, this is VR could work for us. And it wasn't too hard to make the swap over because their pumps and their pivot was already capable of doing this. All they had to do was retrofit the pivot with the individual emitter controlled solenoids. And that's just a little snapshot of the pivot. So in terms of our actual trial, that's our EM map that you saw before. Now this is our current yield map. So that's what we did, Kylie and I did in January. And you can see there really is 3 distinct soil zones. Well, yield zones, I should say. And then we have our elevation map. And you can see that as it's sloping, that's when we're losing our elevation, that's when we're starting to get those drops in the yield, and that is really due to the waterlogging. Now, in terms of how we actually chose all of these different sites, we took into consideration everything. Now, these are all just puzzle pieces in determining what's going on in the paddock. We chose these off the map, but what I want to stress is the most important thing is to ground truth these. So we did a variety of soil parameters, which is what Kylie's going to go through soon for you. Now the map. Now this, I've got on good authority. This is after about 6 bourbons. This was done. This was basically an EM map, and we wanted to see what it would kind of look like. So you've got different rates there, but they're not the ones we're actually using right now. It's just the concept. However, Dean did use this template to build the actual map. Now, this was relatively easy to produce. However, it's not compatible with the Pivot software. So this is where Dean, this is all Dean's, credit to him, because like farmers just didn't put in the hard hours for this. A little crash course on how you develop a map in this software. Basically, this represents your pivot. And now every single section where it overlaps represents a nozzle. And now up the top there, you can see there's all these little colours, and that represents different water rates that you can allocate. What you do is you put a map underneath it, and then you do some arts and craft, and you allocate which water rates to what sections. And this is what Dean has just done here. Now he started allocating the red zone there, it's not very red on the map, is the 0 zone, and then he's just started populating it. And now this is exciting. This is our finished map that we've started using within the last few days. Now this is a combination of an EM map and yield maps, and you can see we've got our low rate, medium rate, and the conventional rate. And then down there, that big red 0 is actually this massive, like, racetrack, I call it, because it's this 700-metre long headland and drain. So this is what Dean's currently using right now. And now this is the pivot in action. A picture paints 1,000 words. So it's doing its thing there. Now that Dean was talking, he was going to put some catch cans out soon to ensure that it's actually doing what it's saying. But I'm going to pass on to Kylie now, and she's going to go through some of those soil ground truthing I just spoke about.
So like Zoe said, it's really important to ground truth. Like, we have all these maps and different spatial characteristics that we can get from a picture or any sort of technology we've got, but we always have to go back to ground truth and make sure it's what actually is happening in the paddock. So at this site, in each of the variable yield zones, we did some infiltration tests. We measured the compaction with a soil penetrometer. We're conducting growth measurements 3 times a week, and we did some soil cores down to 900 mils. So these pictures clearly show the difference between our low yielding, medium yielding, and high yielding areas of the paddock. Yeah, you can see the difference was phenomenal. And then when we did this at that crop stage, we did biomass samples just of the whole plant. So our low yielding was 10 tonnes to the hectare, and our high yielding was 53 tonnes to the hectare. So that is just a massive difference. So you can't try to say that putting on a flat rate of water is going to cater to both of those extremes. So these are our soil cores, and once again, the difference between the high yielding and the low yielding was just like chalk and cheese. So we go from a full clay profile in the low yielding to a clay loam sort of profile in the high yielding. As you'll see from there, the conditions, looking at a soil test, you would probably think that the soil at the top would give you a better result, but because of the waterlogging, the crop just can't utilise what's there. So these are our GDOTs we've got monitoring each zone. This was just prior to an irrigation event. We've got the depths are at 10, 20 and 30 centimetres. And you can see once again that the low yielding area is holding a lot more water than the high yielding area. So in this circumstance, you're limiting your low yielding areas by having too much water and limiting your high yielding areas by not having enough. So this just shows it once again. After a 6 mil rain event, we had water sitting in the row in the low yielding area, and in the high yielding area, it infiltrated with no worries at all. So if you're thinking you have a variable farm and would like to consider something along these lines, you have to have a starting point to know whether it's viable for you. So we're calling it an agronomy audit, so you need to have your mapping, your soil cores, your analysis is done, and you need to ground truth it to make sure it's all true and correct. You need to have the right technology, of course, so that's a good starting point. and you need to, be aware of what's involved in making the maps and all those hard things that come after just buying your product. And you need to fine tune. So we're putting catch cans out now to make sure that what we think is going on is actually going on and it's lining up with our zones just how we want it to. So that's that. Any questions?
Mark Castanelli, Burdekin. Just a quick one. How did you measure your yield?
So we just did a 1 metre cut, and it was just a whole plant biomass, so it was just a basic weighing of that 1 metre cut.
Okay, so it could have a fair degree of variability in that.
Oh, yeah, yes, yeah.
Thank you.
Did you look at the doing anything about, I mean, you had variables in your soil there. Did you look at addressing why that soil was, waterlogging and that type of thing? And I mean, the obvious and probably stupid thing is that, did you look at drainage? But I'm sure you did, but is there other things that you could do to improve that waterlogging?
Yeah, I guess we did look around them, and it's something we're still doing now, and we're looking at what we can do with the soil structure, and not just in this trial. So we're looking at just different practices with what we're doing with trash management and the soil structure and drainage. So we've looked at a bit of it across there, and we've got a fair bit of area under overhead, and there's a lot of other benefits with this as well. Like there's fallow management. I've had it turning off over fallow land that we don't want to water. There's about 6 hectares of area there that's not under crop. So the pivot would normally just water it, but I'll turn that off over that area. So there's a lot of those sort of things as well that come into it. So yeah, but we're definitely looking at the soil structure, and that's part of what we're doing as well. Yeah.
Dean, Rob Slug at Mackay. If it's not a rude question, what's it cost to kit the 400 metre pivot with new solenoid controlled emitters?
It's probably not cheap at this point in time, for an individual one like that. Yeah, you're looking at a couple of $100 a valve probably, but that's something that I think they're working on pretty closely, because there's not a lot. I guess over time it's something that what we're looking for is if it's a viable thing in time to roll out. So we see that price coming down a lot. I can't give you a price. You'd have to go and see your dealer really, yeah. But it's not cheap at the moment, but we see some benefit, and we're going to try and maximise it to its full potential and get a positive cost benefit out of it, and yeah, we definitely see some scope there.
Any other questions? I'll just have one. Return on investment you were just talking about.
Yeah.
Do you see that sort of happening, or have you had a look at that? Is that something that...
We've had a look at it on a pretty high level. It was pretty... When we put the system in, it was a pretty quick decision. We had some modifications going on the system, and we were pretty limited in that time, but we looked at it at a pretty high level, and at what water that we might be able to reallocate to other land that we're saving by not irrigating certain areas, so we might be able to put that water into another paddock somewhere else. And yeah, but it was pretty difficult to put a figure on what value we're going to get out of it, because it's a pretty flexible system. All the benefits you can come from it. Soil is just one thing, but the management of the crops and intercropping, watering a different crop at a different rate on the outside to the inside. So time's going to be a real tell for us. So.
All right.
Yeah, Luke, I just had one question. I was just curious to know whether it was an internal issue with drainage or a surface drainage issue.
It's more... The paddock's not too bad. It's probably got a few little lower areas. I'm probably not an expert to comment on soil structure myself. I'm pretty green with it as it comes out. But yeah, on face value for it's that soil type there, I'm probably not the expert to comment on a lot of it. Yeah, sorry about that.
Tony Crowley from Pharmacists. Just to answer Brian's question, that paddock's been lasered. It's not it hasn't got a hollow in it. It's not sitting down. The water will run out of the paddock quite readily. So it's not a an actual drainage, it's a soil structure issue that's very hard to address in that heavy glue pot type country.
All right, thanks very much. Other questions? Thanks, Kylie, Zoe and Dean for that presentation. I think it's quite interesting to see. Not so long ago I attended a conference in Edinburgh, European Society of Precision Agriculture, and they were looking at variable rate irrigation in vineyards. So it's quite good to see that we're looking ahead of the curve, I guess, and it sort of really is world-class innovation that we're talking about here. So really cool to see that. Next up, we've got a presentation from the wet tropics. So Sam Demoro is looking at a mill mud trial. He farms 530 hectares in the wet tropics region, and we've got Carissa from Terrain presenting on prod services. Oh, sorry, Carissa.
All right, I'll let my crew get up here and give me a hand. I'm going to stand over this side so Sam can have the other microphone and do his bit.
Ready to go? Okay, this is my first time at Project Catalyst, so I'll just have a brief introduction. We've probably I'm third generation, my son's going to be fourth. Collectively, my grandfather's come out in the 1920s, so collectively we've nearly done 100 years of cane farming and we're still learning. So this trial here, Carissa, come and see us. This property here was actually purchased in 2013, and Chris had done some soil trials there, and we found we were lacking in potassium. So we decided to try these mill trials, mill mud trials, so I'll get it right. And go on.
No, you're right, Sam. The other thing we're finding on this country, this is ex-cattle country. It's only been under cane for 3 years.
Yep, that's it.
So there's also some other underlying soil structure and other issues as well. So we're trying to look at soil biology and help improve soil structure as well, and that's why we looked at mill mud for your last ratoons. The map here on this side is your strip trials. So what we had is we had Sam's standard liquid fertiliser that he uses, which is 14% nitrogen, 1% phosphorus, 9% potassium and 1% sulphur in this season. And he applied that at 1,000 litres to the hectare. The second treatment is we put mill mud at 100 tonne to the hectare, banded over the stool, and we added only 350 litres of his standard fertiliser. And the third treatment was just 100 tonne to the hectare mill mud on its own.
Yeah, so as you can see with the soil trials, that was low in potassium, so the structure, poor skill structure, but not completely through the whole farm. It's just little areas through the paddock. As you get closer to the creeks, obviously the soil improves. So we come up with this point of putting out the mill mud, hoping to, but we've only done it once, so it's going to take a little bit of time to actually continue on with these trials and see how it actually improves the soil and getting into organic type urea and stuff and getting away from the inorganic type nitrogen. And also Chris had decided to put it on as returns instead of putting it out in fallow, that we'd get a benefit and because actual mill mud takes a little while to break down, so that's why we decided to put it out in your returning paddock before your fallow.
The other reason for putting it in your last ratoon is we all know that the quality and the nutrition in mill mud is quite variable. So putting it on a last ratoon crop is quite low risk if you don't quite match the nutrition correctly. So with that, it allows the mill mud then to break down and be in the soil before we do our soil testing for our plant crop, rather than doing your soil testing for the plant crop in your fallows and then putting your mill mud on and not knowing, well, how much has it really added into the system and how much is really available. So it's trying to account for a little bit of that a little bit better. So these are the trial results. So basically, this is our trial that we ran in 2017. Across tonnes of cane per hectare that we cut, tonnes of sugar per hectare that we had in CCS, across all 3 treatments, there was no statistical difference for this season. So that was a 3 treatment, 3 replication. There is quite a bit of variability in it because it is an old ratoon, so there is some bare patches and that within it, as happens. But as you can see there, it wasn't a high yielding crop because it was cut late the year before. It had damage in it, but we didn't lose any yield in there at all. This is a similar trial that we ran up at Litres with Sam in 2015. Now the difference between 2015 and 17 was our climate or our weather. 2015, we didn't get any rain until quite late after ratooning. We didn't have a wet season. So what happened there is we put mill mud at 100 tonne to the hectare, and we put Sam's fertiliser that he was using at the time at his standard rate, which was 1,100 litres to the hectare, and at 600 litres to the hectare. By changing it from 1,100 to 600 litres to the hectare, there was very little difference. The mill mud is not showing on here. For some reason, it's done something strange. The mill mud had statistically, it ended up with a lower tonnes of sugar per hectare because the CCS was down a bit, because the mill mud became available too late because of that rain sort of May and then harvesting in August, September. And it didn't get that initial kick when we originally put it on. So the risk with going straight mill mud is if we have a dry season, is it takes too long for it to become available to the plant. So that early on, the plant can actually lose some growth because there's not enough nitrogen in the system for it. So as a safeguard, we're finding we need to put a little bit of fertiliser with it just to give the plant that early kick in case the rain is a little bit late and we don't get that breakdown of the mill mud until later in the season. I'll get Titch to come on and go through the economics for it. Titch is another person from DAF. He's just newly joined them and he's done the economics here for us.
Thanks, Carissa. So we looked at the costs associated with the 3 treatments. So the one with the highest cost was the one where we used the mill mud and the fertilizer applied to the treatment. So that was at a cost of $723, as shown in the with the blue. So the dark blue for $560 for the 2 is the cost of the mud to the applications, and then the lighter blue is the cost of the fertilizers. So with the first treatment, that's the normal treatment that Sam does, which was just the fertilizer at 1,000 litres of that fertilizer per hectare. The second treatment was the mill mud with the fertilizer, 350 litres of fertilizer per hectare, plus 100 tonnes per hectare of mud. That was the most expensive of the 3 treatments. And then the third one, which was just the mill mud, at 560. And then the other costs were generally the same except for the harvest costs, which were proportionate to the quantity harvested of the 3 treatments. So those are the costs there. Yeah.
Just a quick note there. Just some of those, the biggest cost of that mill mud is not the mill mud itself. Sam's farm for this one is quite a distance from the mill, so the biggest cost there is actually the cartage. So the cartage is included in that.
So calculating the gross margins, which was the difference between those variable costs and the revenue. The highest gross margin was with the no mill mud applied. So that's the first treatment. So that's the full fertilizer application and no mill mud at $80 per hectare. The second treatment, where fertilizer and mill mud were used, actually had a negative gross margin of $110 loss per hectare. The third treatment only giving us a positive gross margin of $1 per hectare there. But as Carissa has highlighted that with the mill mud, it's the cost of the mill mud that's essentially playing a part there. So a farmer who might be closer to the mill would probably experience a different gross margin scenario to this one. Yeah.
The plan for this trial now is we've harvested it very late last year, December, with an infielder. So you can imagine what some of it looks like. Unfortunately, Sam had a very wet plant and he lost about 50 hectares of plant cane. So he's taken out half of this paddock and left half of it to ratoon. So what we're going to do is we'll still take this through to plant cane because he'll fallow the section that is fallow, and if everything goes well, he'll do a play-out replant, which is less than ideal, but he'll do a play-out replant where he has left it go around again due to the loss of his plant cane last year. And what we'll do is we'll take that through to see, we want to see what the benefits are and whether they carry through to your plant cane. So we're not looking at this for just a 1 year benefit, but we're trying to look at it for longer term. We've also got to go and do some soil tests to see if there's differences in nutrition and whether we can tweak that nutrition rate in our plant cane come time for planting. Now, Sam's got a really good reason for doing all this. He has a passion for fishing, along with his family. So this is, his son Jason is with him this week, these next 2 days, but this is his other son, Matthew, and his 2 daughters. So this is 4th and 5th generation coming through. So this is why we're looking at doing all these sort of things.
Question in the back. John?
Thanks, Carissa. Just a quick question. The gross margin analysis was done with mill mud plus full fertiliser rate. Did you apply a mill mud plus half fertiliser rate there?
Yeah, the analysis was done on that one as well. There was a full fertiliser rate with no mill mud. There was a mill mud with a low rate of fertiliser and mill mud on its own. That was the 3 scenarios that were analysed there.
I thought it was just mill mud only plus full fertiliser rate.
No, the full fertiliser rate, hang on, we'll go back. Oops, can't. Give us a sec. Yeah, the first column had just the, I think just light blue, which was just the full fertiliser rate. The second column had dark blue, which was mill mud, plus a little bit of light blue on top, which was your mill mud plus your no mud full fert.
Oh, sorry.
Yeah. Confusion, no mud, full fert. So this was just your full rate of fertiliser with no mill mud. This was your mill mud plus a small amount of fert, and that was just your mud only.
Okay. Are you going to do analysis this year on the soil properties to see what is still left over?
Yes, that's the plan, John.
Yeah, Carissa, I'd just like to see the analysis next year on the economics. If you're not going to apply mud next year and you get that benefit, the gross margins might change a fair bit because you haven't got that cost.
That's something we'll need to look at once we've done plant cane, because this coming season it'll be fallow and some plough out. Can we analyse that plough out to see if there's any difference there with new areas and that. But I want to take this right through to the plant cane and the yield of the plant cane to see if we're getting benefits there, because we're looking at the longer term benefits, not just a one season, one crop sort of benefit out of this.
Plus the other thing too, Ray, there was, 2 varieties there. There was 241, which is not a known sugar variety up in our area, and there was 231 we cut at the end of the year, which should be an early maturer. So that probably knocked the sugar around a bit too.
I did block it, so that was taken into consideration. So all 3 treatments were put in both areas evenly. So that has been accounted for in the statistical analysis.
Yeah, Chris, how's the mill mud applied? On the top or on the bottom, or where was it applied?
Side. It's side. Just applied with a truck, the normal Tully mill trucks, and they got stainless steel little deferters, and they
so you just can't apply it 3 rows and spread your cost out that way?
Yeah, that's right.
All right, thanks very much, Chris and Sam. And I think it's really good that we're looking at alternatives to synthetic fertilisers, and you know, bearing in mind in that second keynote this morning, presented by Ken Anthony, that we're really sort of looking at the environmental benefits, and at the end of the day, the bottom line, particularly when it's looking at nutrient inputs. Next up, we've got Heidi Hatch from Pharmacist. She's looking at innovation and innovative technologies in irrigation and different techniques on how to further your water use efficiency. And Billy.
Yep, and sorry. Got it. So today, Billy and I are going to be presenting innovative irrigation tools in a furrow system. So as Les said this morning, the Burdekin is Australia's largest sugar producing region, and there are various characteristics that differ us from the other regions. One, that 2/3 of the room probably don't like to admit, we have a higher district yield potential, because everything is bigger in the Burdekin. I'll go back. But of course we have a lower relative rainfall. And because of this lower rainfall, we require irrigation to support these higher yields, and this is predominantly done through furrow irrigation. So unlike places like the Herbert, who have no control over their water received, we do through irrigation, and we need to use this to our advantage. So with this comes the responsibility of managing and improving our water quality. So, sorry, this keeps squeaking. So we want to reduce our water, nutrient, pesticide and sediment losses. And if we can reduce our water losses, we're ultimately reducing these last 3. So this can be done by matching the water applied to the crop requirements. And this can be done through 3 components. So number 1 being we have control over the frequency. We have control in the Burdekin over how often we can irrigate our crop. If we're irrigating too often, we're potentially risking waterlogging and the chance of denitrification, so the ends going up. And if we're not irrigating enough, well, potentially losing yield. We also have control how much we're applying, and if we're putting too much on the paddock, it's pretty well going out in the tail drain, and we're losing it as runoff and whatever else is in the water with it, and as well as deep drainage. We also have control over when we irrigate in regards to applications of fertiliser, chemical and emollients such as mill mud. So I have a little graph here highlighting irrigation timing in regard to fertiliser application. So I'm not sure if you fellas at the back can see the laser pointer, but down the bottom we have the irrigation. So we have first, second, third, fourth irrigation. And up on this axis, we have total N losses as runoff in kilos per hectare. So the crop was fertilised here, and this is the first irrigation. So not much is coming off, and the different colours are different N rates. Then by the time it comes to second irrigation and the ammonium's being converted to nitrate, which we have more potential of losing it as runoff and as deep drainage. So this is when we're seeing the spike, and then it slowly drops away. So that's from a catalyst trial from last year. And then this is from another catalyst trial in the Burdekin about 2-3 years ago. and it is in, but it's in DIN concentration. So again, we've got the irrigation events down the bottom, only a little bit in the first. Come the second and the third irrigations, we're seeing this massive spike. And we need to remember that when this is happening, the second and third irrigation, it's when the cane is quite small. So we need to just be careful that we're not over-irrigating little cane so we can try and reduce this spike. So how can we do this? It comes back to scheduling. So we have a range of management tools that we can use to schedule. So most of you know of the GDOT. Pharmacists are developing a wireless moisture monitor, and we have a water alert sensor, which was commonly known as the end of row sensor. So we can use the data that we're getting from these tools. So it's numbers, it's real-time data that we can use to make informed decisions. So which we're improving crop utilisation, reducing runoff, minimising that risk of waterlogging and potential denitrification, and also saving you guys money. You're not putting on the water if you don't need to. So I'll just do a summary of the GDOT. Most of you guys probably know what they are. We've seen extensive adoption in the Burdekin. But for those of you who don't know it, there's a little gypsum block that's in the paddock, and this is a little head unit that's on the headland. And when the soil's wet, all these dots are lit up, and as it dries out, they slowly flick off. In a bit more complex terms, it's a measure of how hard the plant is working to extract the water out of the ground. So up here, when it's wet, it's not working that hard. It's having a good time. There's not much of a lineup at the bar. And as it dries out, they drop off. And down here, it's working really hard to get a drink. And while it's working really hard, it's not producing biomass, and it's pretty well, you know, you're losing yield. When it's working this hard, you're losing yield. So it's just a really good, cheap tool to indicate crop requirement. So many thanks to Bill McAllister, who's, it's his birthday today, and Rob Sluggots. And also thanks to Sarah, they've been calibrating the GDOTs on a range of different soil types across the Burdekin. So that's as part of the Catalyst adoption projects. So what's involved with calibrating? We've been using the same method that was developed by BSES about 20 years ago, and there's also an SRA information sheet outlining the process. So like I said before, the little gypsum block that's in the paddock, you go into around that area, pick 24 sticks and go in and mark them and measure them at the same time every day. So that's to the top visual dual app. So once you work out how much it's growing each day, you can monitor this and you can work out your maximum growth. So in the Burdekin, we're reaching like 40 mil a day. And then when it drops to half of that, for 2 consecutive days, that's deemed your irrigation trigger point. But I'll show you a little graph outlining that. So don't be overwhelmed. So we have growth up this side in mils per day, and like I said, we're reaching up to 40 mil per day at this time of year. And down the bottom here, we have days after irrigation. So it's irrigated here. The crop starts to respond, it's picking up, and it's hitting a peak up here at day 3. And as the soil starts to dry out, the growth per day is decreasing. Remember how I was talking about the KPA and how hard the crop is working to extract the water? We can also graph this. So here, remember it was irrigated here. On day 1, the KPA is really low. So the soil's wet, it's not working very hard. And as the soil dries out, it's working harder and harder and harder to get the water out. And then we can see when it's working hard up here, our growth per day is suffering. So this is when we need to start irrigating before it starts suffering. So our peak growth is up here at 34 mil per day, and half of that is 17. So we can put this orange line in there. And then it drops below this line on day 6, and then 2 consecutive days is day 7. So this is when we're recommending to irrigate. You can come up here and find the KPA. So it's 35. And then you can take, on your GDOT, that's 3 dots. So on that paddock, on that soil type, irrigation trigger point is 3 dots. So these G-dots are great for maximising growth because we know when to irrigate. They're improving our efficiency. We're giving the crop the water that it wants when it needs it. We're potentially putting on less water, reducing our losses and saving you guys money. And also in some heavier clays in the Burdekin, we've seen guys that want to get in there and irrigate, and we go in with the shovel and we dig up and it's still wet on there and they can't get over it. So we're really potentially reducing this risk of waterlogging and denitrification. But with the G-dot, there are some limitations. So typical G-dot you get, it's got the green cord, it's about this long, but at Pharmacist we're extending it 20 metres, but we're still confined by that length of that cord. We're coming in from the top of the paddock, but you can come in from the side, but we're finding practicality issues. So you got your cord and it's running across the drills, you come in with your urban legs or something, you're going to pick it up and potentially rip it out. And we've seen that happen. Not looking at you, Willie. No. So then you've got this one G-dot and it's in your plant cane and you're scheduling your whole farm off this one G-dot. But it could be on a different soil type, you know, that's in your plant cane. What about your young ratoons or your older ratoons? So there's the potential that's all going to be different. So an example is, say this is your paddock, this is the boundary here. You've got your G-dot, which is this little red dot, and looks all fine and well. I'm like, yep, I'm going to schedule my whole paddock off that. But when you put a soil layer over the top, you've done your growth measurements on this little orange, this is a different soil type, this orange soil type, whereas the majority of your paddock is in fact a completely different soil type. So what you've calibrated up here could be completely different for the rest of the paddock. So that's definitely a limitation. They have an inability to store data. You don't know what the bloody thing was reading last week. And you have to be present on the headland to see it. So what if this gypsum block could be placed anywhere in the paddock? You weren't confined by that 20 metres around the edge. And what if the number of dots that it's reading, or the KPA, could be sent to your phone in real time? And what about if this data was available on every paddock? So pharmacists are in the process of developing a wireless soil moisture monitor and telemetry. So it's connected to a network and it reads the soil moisture data. It's automatically uploaded to our network. You can monitor it instantly and it's on your phone in real time. So this is a little prototype that we have in field at Willie Lucas's. On your Willie. So the end goal that we want to get out of these wireless, pretty well wireless G-dots, is to have a farm map like this one, colour-coded differently to indicate different soil moisture requirements. So, for example, this part of your farm, these paddocks are green, so they're not experiencing any moisture stress. And these little Wi-Fi little symbols, they're representing a G-dot, so they can be in the middle of the paddock on your predominant soil type. And they actually have a number. So on your G-dot, how you've just got a range, like you'll have 10 to 20 or whatever, it's a range. These are giving you an exact number. So down here, you can see this is 32. It might be green, but very soon it could be hitting orange. So just to keep an eye on this paddock. Then we've got the orange, which are experiencing moderate stress. And again, you've got the your reading. And then red is severe. And also, we're hoping to make them cheap enough that you can potentially have 2 in each paddock, so like this one up here. So the benefits of this is that we're accounting for different soil types. On this farm, actually, this is a much heavier soil and it goes up onto a ridge. This is a ridge here, and it's a lot sandier up here. So obviously, this is holding the moisture more than up on the top here. And it's also accounting for crop stage. So it's not coming back to just having that one G-dot in your plant crop. Like I said before, it's real-time monitoring, like you're getting instantly on your phone. Like you can be here checking on what your paddock's doing. You have the potential to increase productivity. We're water budgeting. So these in your normal set rotation, which a lot of Burdekin farmers are on, they'll just go round and round this paddock. But on here, we might skip this paddock and come back and do this red one. So it's really good to
for their water budgeting, and especially putting more water on those, on like your plant crop or your first ratoon. And especially after rain, because you're always guessing what paddocks you're going to water next or first after it rains. Sorry, we'll just go back. And we also have the potential of cost savings, such as water, electricity, and labour. And we're potentially reducing, again, that over-irrigation, so reducing runoff, reducing our denitrification, and environmental stewardship. I'll hand it over to Billy to talk about the sensors.
Not sure if I can follow that, but so recently, well, in the last 12 months, Pharmacist has been working on a water sensor, which it was called the end of row sensor, and we've recently rebranded it as a water alert sensor, as we've realised it has a lot more functions than just putting it at the end of the paddock. So it's a very, sorry. You have a foot, like you're a foot taller than me, Heidi. So it's a very simple, low-cost sensor. Open-close circuit, sorry. So when the water bridges the prongs, it tells the sensor that it's wet and sends them notification to the grower. As the water falls away, the connection's lost and it says that it's dry. So all of the sensors connect to a low-power radio network that's powered by Taggle. And we have 3 base stations currently set up in the Burdekin. We've got one on Davco's Hill, one on the silos at the Rocks Farms, and one on the water tower in Home Hill. And that has given us coverage of about 95% of the Burdekin, give or take. And so here we're looking at a primary benefit of reducing unnecessary runoff and deep drainage. So where Heidi was talking about, now we know when to apply the water, now we're working on how much to apply and when to turn the pumps off. So potential uses for the water alert sensor, besides the obvious bottom of the block to alert us when sets are finished, the sensors are very easy to move around. So if most of the sets are down and you've just got a few lazy drills, you can move them into one that's not coming down as fast as the rest and then turn the pump off when they're finished. Some growers have shown interest in wanting to put them on cylinders that they know overflow. So especially important if that cylinder's next to the neighbours, and that way you can turn the pump off or fix the problem before you flood them out. There's also been interest in putting them in recycle pits. So if you had a sensor at 80% capacity and 20% capacity, when the sensor at 80% activates, it's time to use the water in the recycle pit, and when it hits 20%, it's time to turn that pump off. And then a recent one we've been actually working on through Catalyst is using them to record irrigations. So at the moment, there's not very many people in the Burdekin that record their irrigation use or their water use. We're one of the biggest, if not the biggest, irrigated area in Queensland, and there's not many people that can tell you how much water they use. So one of the strategies we're trialling is installing a water alert sensor at the top of the block. And so it will activate when water hits it, and then when the pump's turned off or the set's changed, it will say that it's dry. So that's just one actually at one of the nitrate trials. Because the sensors are easy to move around, and every time they have a change of state, so they go wet to dry, they also GPS stamp wherever they are. So one potential use would be to move them across the block as you change sets, and there you've got a GPS referenced irrigation record. Yep. So why is it important to start collecting this data? So like I said before, one of the biggest irrigated areas, and we don't know how much water we're using, at least in the delta. And if we start collecting and interpreting this data, we can start to fine-tune our irrigation strategies, whether that's allocating water to higher yielding blocks. We can start calculating water use efficiency data, figures. So in terms of tonnes of cane per megalitre applied, in your plant cane, you might push more water to it, and you know your older ratoons aren't yielding. Electricity is not getting any cheaper, so in terms of saving costs. And yeah, so anyone that wants to get BMP or Bonsucre accreditation needs to be recording their irrigations, and this could just be one way of making it a lot simpler. So we are doing a bit of this and the water alert sensor stuff with Project Catalyst. However, the majority of it is through a project with NQ Tropics Sustainable Ag Program, which we're collaborating with Lawrence Pavoni on. I have to say thank you to David Cox, the Rocks Farms, and Burdekin Shire Council for hosting our base stations. Taggle for assisting us with the base station and end of water alert sensor development. And nothing would happen without the pharmacist staff, like Jason climbing up silos so we don't have to. Any questions for Heidi or myself?
Hey Heidi, you know me, Shane Butler from Fowles Farming in Proserpine. Have you trialled with your GDOTs? How far down to put your gypsum block? And have you tried different levels?
So at the moment, the GDOTs are installed, the gypsum blocks are installed about 25 to 30 centimetres down the profile. But the depth will vary depending on like bed height and or potential rooting zone. It's really a case-by-case basis a bit there.
Yep, thanks.
But sorry, we're also, when we do the calibrations, we're calibrating them at 25 to 30 centimetres.
Yeah, I just got a question about your sensors. How are they going to go? Are they going to be subsurface, and are they going to be able to transmit when there's a full crop growing there, or do they have to be pulled out in between?
Which sensors?
The ones that Heidi was talking about, for irrigation monitoring on different soil types within the block?
At the moment, we're planning to bury the actual unit, and they'll have a cheap, we call it antenna. Yeah, and they'll stay there potentially for the whole crop cycle.
And they'll transmit in a full crop?
Yes, that's what we're hoping to do. We've done testing in previous years. Should be good.
Heidi, stay there. Nothing to do with irrigation, but back at that first slide there, you had different rates of nitrogen, different amounts of water. Have you got those figures? Because we don't irrigate,
yep.
And it's just curious to me, I'd like to know how many days after applying fertiliser, how much nitrogen loss we're getting. So those 3 bars you had there, do you know the rates off the top of your head?
The rates were down the bottom, but it's from a trial that Alice is actually going to present on tomorrow.
Yeah, no, because you're putting nitrogen on,
yeah.
And you're getting your highest loss at 9 days, I think. 19 days.
Yeah, so this was the second irrigation event.
Okay, so what's the different coloured bars for?
This was a trial, a catalyst trial that Alice is going to talk about tomorrow. So the light blue is 110 units of N, 150 and 190.
No, the reason why I ask is for us in the wet tropics, we're applying fertiliser on the 2nd and the 11th and we don't get any high rainfalls to the 16th or 12th, our nitrogen losses are going to be minimal.
Yeah.
So yeah, I'm just looking at it at a different angle, that's why I just want to know. How many inches of rainfall does that equate to in your irrigating?
I do not have the answer to that one, sorry.
Each one? Okay, thanks.
Just one comment there. The spike there is, so in the first irrigation, that's where it converts from ammonium to nitrate, and then in the second irrigation, it's in nitrate form, and that's where it can get pushed through the profile or pushed out.
Any other questions? No?
I'm just going to do a runner. They're still, we're still in the process of developing, so I can't answer that one either, sorry.
All right, if that's it. Last one.
Yes, potentially.
All right, thanks very much, Heidi.
The antenna will be a sacrificed antenna. It's going to be a low-cost antenna. The device itself, along with the moisture sensors, will be buried underground, and everything will be underground. The only thing that will be above ground is a sacrifice antenna based on probably a bamboo stick or something like that. The harvester won't have any trouble chewing it up and it'll be spat out.
All right. Thanks very much, Heidi and Billy, for that presentation. I think we're slightly ahead of schedule, which is good. We've made up some time. I think across the board there were quite a lot of interesting topics there, from variable rate irrigation to alternative nutrient sources for input, techniques and different tools that you can utilise to better refine your nutrient and water use efficiency. It's, I guess at the end of the day, it's the common themes that are sort of coming out is saving more money at the end of the day through improved water use efficiency and nutrient application. And I think as we head into the next session in nutrient after lunch, it'll be good to see how the linkages sort of work into nutrient and with water being the main transport mechanism of nutrient leaving the farm. So a big, I guess, emphasis on nutrient leaving the farm in the next session, and water being the main transport mechanism. So thanks very much, I guess, to all the presenters for those presentations, all the growers as well that sort of came in and assisted. And Craig's flagging me down for something.
Is that working? Yeah. Just yesterday I was asked to sort of do a brief summary of each of the sessions, so I'll probably just do that now. And it was one of the things that was a bit of a feedback from last year, that there was so much information being put out there that they just wanted a bit of a summary of each session. So this is my interpretation of what's been summarised, or summary of what's happened so far this morning in regard to water and a little bit of nutrient in mill mud. Obviously, one of the take-home messages for the water in the Burdekin is the groundwater in some instances does have a lot of nitrate and has to be accounted for. And it's interesting that the trials are now coming down to much lower rates, than down to 100 and 125, I think, in the next lot of trials. So it'll be interesting to see what CCS comes out of those really low rates of nitrogen, and maybe even some adventurous growers might even want to go down below 100 and see what happens after that. So I think it's obviously a trial, I think, that needs to be continued and monitored, because at the end of the day, some decision-making tools can be implemented out of that trial to help growers with that groundwater. And it's not just in the Burdekin. I think it's happening probably certainly in a lot of regions that irrigate. So it's just not applicable to the Burdekin. Variable rate irrigation. It's something that we've sort of been really closely monitoring, and it's interesting that one of the biggest hurdles we had, and Dean will probably testify to it, is the incompatibility of producing a map in a spatial software to the pivot software not being able to accept it, and the amount of time taken to make that map. So just be aware that horses aren't, there's horses for courses, and you need to account that sometimes the software that you want to work doesn't really work all that well without a lot of manipulation. The take-home message from there is, every time you want to do something different on your farm, you do need to ground truth and analyse the situation before you make the decision to make a hefty investment into making some changes. Because in this case, the analysis said there is some really strong variation occurring on the farm, and therefore the investment could well be worth it. So ground truthing and analysis is so important, not only just for irrigation purposes, but for any changes. The mill mud, it's interesting. I think one thing that's going to be interesting is what happens to that site over the next couple of years. Certainly in some of the trials that we've conducted in Mackay, the benefit from mill mud was certainly there were certainly benefits in the second and third year. So it'll be interesting to see what happens on that site in year 2 and maybe even to year 3. So worthwhile seeing what happens in the future years on that site. And the innovation in water, especially for the Burdekin, but also it's applicable to anyone that irrigates Mackay and further south. if we can save water, everyone knows what the water costs are and what irrigation costs are with either diesel or electricity. So if we can save water, it's the most important saving I think we can make, certainly in the Burdekin. But having said that, the GDOTs I think are a really cheap and efficient method of determining soil moisture, but just be aware they do have limitations. I think that's a brief summary of where we got up to, and if anyone has any other comments, because we are a little bit ahead of schedule, I think.